Today is Wednesday, September 25th, and we are starting our second official live class. Just so you are aware, so far you should have completed a Check Your Understanding quiz. So the only thing for marks presently at this point in time is that one quiz. The diagnostic test/quiz is not for marks, and the IP quiz is just for me to know who has IPs, so that's not for marks. So the only thing for marks so far is that one quiz. The deadline was on Monday. I extended it. It was due last week. I said, you know what, for the first quiz, let's just give you guys a little bit more time. And yeah, so I extended it. But it was due on Monday, so you should have completed by now. There's a few students that did not complete it, and I will be emailing those few students. Or if you want to email me, you can email me. Okay, now let's get started on today's lesson. So today's lesson is all about. Honestly, I don't know what it's about. Let's figure it out. Lesson 3, 1.3, factored form polynomial functions. Yes, remember you can always watch the recording, so you can go. In this section, you will investigate the relationship between a factored form of a polynomial function and the x-intercepts of the corresponding graph. Then you'll examine the effect of repeated factor on the graph of a polynomial function. So let's figure this out. So first we have a graph or a function that looks like x to the power 4 plus 3x cubed plus x squared minus 3x minus 2. And it would be useful to look at the factored form of this version. So we have to learn how to factor this. That's number one. Once you learn how to factor that, you have something like this. Now, if it's given to you in factor form, which for now we're just going to assume it's giving it to us in factor form. So if the function is in this form here, let's start by looking at the graph. This is what the graph looks like. From the graph, let's answer some of the following questions. Well, what's the degree of the function? We know that there is 1, 2, 3 turning points. So if that is the maximum amount of turning points, we know that the degree is probably 4. But is there another way to figure that out? Let's find out. Well, we just look at the highest degree. If you have the equation, we know x to the 4 is the highest, so the function is degree 4. What's the leading coefficient? Once again, we will look just at the coefficient. Leading coefficient is 1, therefore the leading coefficient is positive. X-intercept, what are the x-intercepts? Well, we know the x-intercepts are -2 and 0, -1 and 0, and then 1, 0. So they're all, there's 3 x-intercepts, sorry. But there's some differences between the x-intercepts, and that's the order of the x-intercept. What do I mean by the order of the x-intercept? So x-intercepts tell us a lot about the parent or the original function. And if you take a look at this first x-intercept here at -2, 0, the function is going straight down, and it goes through the x-intercept as a line. So it's very linear. So if I were to just zoom into that one section where the x-intercept is and just kind of see what's happening, the pattern there is just going straight down. So that's kind of like a line. So that would be the order of 1. Because a line is a function that's just y equals mx plus b, or x to the power of 1. So that's the order of 1. It's linear. Now, if we take a look at our second x-intercept, we see that if I zoom in, what's happening here? It's going, and it's kind of coming back. It kind of looks like a U shape. And a U shape is indicative of a parabola or a quadratic function. And so this x-intercept has the order of 2, because a quadratic is x squared, or the x to the exponent 2. And this is going to help us determine the main function. Remember, we're only looking at the x-intercepts. We're not looking at any other points. We're not looking at like the local minimums or the y-intercepts. Right now, we're just focused on the x-intercept. So there's 1, 2, and there's one more. And that final x-intercept is very linear. So therefore, that's also going to be in order of 1. So this is what they mean by the x-intercept are order of 1 or order of 2. And what's the y-intercept? Well, that's just 0, -2. All right, so what can we do now with this information? We are going to split our domain. So the x-axis, we're going to split it into certain sections. And we need to figure out certain critical points. How do we figure out critical points? Well, critical points are asymptotes that occur on the graph or x-intercepts and sometimes holes. So here we have an x-intercept at -2. So the graph gets split. I'm going to visually show you exactly what I mean. So here we have our, oh, nope, here we do not have our anything. It didn't get pasted. Let's try this again. Okay, and there we go. Here's our graph. And I'm going to draw a vertical line here to split the x-axis. So anytime I see an x-intercept, you don't have to draw it. You just have to kind of know that there's a split, and this is my key point. So this function doesn't have any asymptotes or any holes, so only x-intercepts. So here we have a region of the function that is to the left of that x-intercept. So that is going to be from -∞ to -2. Close bracket, close bracket. We don't include the key point. So that's our first section. There is another section of our graph that's between these 2 points, and that is between -2, comma, this is -1. Then we have another section. Oh, I think this is, oh, there you go, blue. And then we have another section that's from here to here. That's from -1 to +1. And then we finally have the final section that's over here, and that is from 1 to +∞. So these 4 sections, when you add them together, equal the whole domain, the whole x-intercept from -∞ to +∞. We just split it into certain areas. Why do we do that? We do that to figure out certain properties of our function. So once we've done this, once we've divided our intervals up into the 4 sections, and just so you know, this function and this graph got split into 4 individual sections, different sections. Other graphs might be only split into 2 sections, or might be split up into 10 sections. It really depends on the function and how many x-intercepts and asymptotes there are, and holes. So let's do a test point. What do I mean by that? So here, what I'm going to do is I'm going to grab this table, and this is what we do. Anytime we want to figure out whether the function is above or below the x-axis, we do this. So here we have, what are the intervals again? I should have just copied the one with the intervals. I don't remember. Let's see if that works. Yes. Okay, there we go. So here we have the intervals. Let's line it up. So from -∞ to -2. Test point. What do I mean by test point? You have to pick a point that exists within this interval. So what's a number that's between -∞ and -2? And you can't use the end points. So I usually just pick a number that's close to the end point. So -3 seems like pretty simple, because it's more negative than -2. What about -2 and -1, the next interval? What's a point that's between these 2 numbers? A lot of you might think, hey, well, there's really nothing between -1 and -2, right? I mean, what whole number is there? And, well, there's no whole number between -1 and -2, or integer, I should say. But there are numbers. For example, decimal numbers or fractions, so -1.5. Between -1 and 1, this is where a nice point that I always like to take whenever I have a chance to take, and that's 0. Why? Because when we're substituting 0 into our equation, it makes the calculation so much easier. So a number between -1 and 1, well, 0. And then a number between 1 and infinity, you can literally use 100, 1,000,000, 1,000, whatever you want. I don't know, you can pick 2, or you can pick 5, whatever you like. I like to pick numbers close. That's just me. I like small numbers. I don't like to deal with like a million, values. Okay, and now the sign of f of x. How do we figure out the sign? Two ways. One way is to substitute it into our equation. So here's our equation. And we are going to substitute the value into our equation. So f of -3 is equal to -3 plus 1 squared, bracket -3 plus 2, bracket -3 minus 1. Then we simplify. So -3 plus 1 is -2 squared. -3 plus 2 is -1. And -3 minus 1 is -4. And now we multiply the -2 squared. That's just -2 times -2, positive 4. And the -1 times -4, that's just positive 4 as well. And we have an answer of 16. So we are not really looking for the actual value or the magnitude of the number. All we care about is the sign. So that's a positive number, so we write positive. Now for our next interval and our test point, -1.5. Same thing. We do -1.5, plug it in. I'm going to show you a different technique. This technique works, and it's perfectly fine. I'm going to do something, just a different technique, just so you guys are aware that there's different possible ways of doing this. So another way to do this is to make a table of values as like the one we have up here. I'm just going to actually copy this. Okay, so we have an interval, but then this axis, we are going to write our factored form. We're going to write each individual factor. So x plus 1 squared, that's kind of like one factor, you could say. If you want to split it up and write x plus 1 twice, that's fine too. It doesn't really matter. X plus 2 is kind of our second bracket, and x minus 1 is our third bracket. Okay. And then we make our table like this, and then we have our sum, total, or function. So what do? Same thing as the previous example where we find a test point. So -3, just make it a habit to write whatever point you're substituting in above that interval so you can see if you're doing it right or wrong. X plus 1 squared. Let's plug in -3 here. So -3, plug it into here. I'm going to give you a hint. Anything that goes inside this bracket, if you square it, it's going to be positive. And all we are writing is whether that factor is going to be positive or negative. We don't care what the value is. We just care what the sign is of the final answer. So if I substitute -3 into here, that's -3 plus 1, -2, but then you square it, it becomes positive. So that's a positive answer. And I can do this across because, as I mentioned, anything I plug in here, if I plug in -1.5 in there, once again, that's -0.5, but I square it, so it's positive. And if I plug in 0, that's just 1 squared, that's positive. If I put 2, 3 squared, that's positive. So this section is just going to be positive. What about x plus 2? Well, if I substitute -3 here into x plus 2, we get a value of -1. So here we're going to have negative. And if I want to go across, I can do -1.5, which is going to now be positive because -1.5 plus 2 is positive a half, which is a positive number. Next, we have 0, once again positive, and 2 2 plus 2 is positive 4, so that's positive. Final factor, x minus 1, plug in or substitute or input -3, so -3 minus 1.